If you look at the layout of a typical suburban neighborhood, you'll see a near-perfect habitat for an opportunistic bird. We've built wide, open fields of grass, perfect for foraging, and lined them with tall trees, ideal for nesting and keeping watch. But step into one of those parks during nesting season, and that peaceful setting turns into an active combat zone. You're walking along the path, and suddenly, a dark blur dive bombs straight at your head with terrifying precision. It's a jarring contrast. For some, these birds are the singing maestros of the morning, delivering glorious melodic calls. For others, they are simply terrifying aerial antagonists. To understand why they attack, you have to look at the real estate. Space is highly competitive in the suburbs. Over 100 birds might vie for control of a single park, dividing the map into strictly defined territories of just 200 or 300 meters. They defend these invisible borders 24 hours a day, all year round. A single bird might spend 10 to 15 years living in that exact same patch. That is their entire life. Every single day is a battle to hold on to their home. That aggressive swoop is a calculated defensive maneuver, a necessary survival tactic for a bird that has spent a decade fighting for its specific patch of ground. In fact, if you watch closely, you'll notice they rarely attack indiscriminately. Only a small fraction of males actually swoop, and when they do, they are often targeting specific individuals. Researchers tested this by wearing masks of human faces that had previously scared the birds. They discovered that Australian magpies can recognize and memorize the distinct faces of dozens of different people. If you slide a magpie, it will remember exactly who you are. They've even been known to hold multi-generational grudges, continuously targeting a specific person or even someone who just looks like them years after the original offense. Storing and recalling that level of precise visual data requires serious processing power. It prompted researchers to stop looking at these birds as pests and start putting their cognitive limits to a formal test. The first test is a simple game of association. Researchers place a piece of food in the grass, hidden beneath either a yellow or a blue cap. Through a bit of trial and error, the bird quickly figures out the pattern. The treat is always located under the yellow cap. But then, the researchers change the rules without warning. They move the reward under the blue cap. This tests a concept called reversal learning. The bird has to recognize that its previous strategy is no longer working, abandon it completely, and figure out the new rule. Magpies pass this test easily. They don't just rely on ingrained habits, they actively analyze new information and adapt their behavior on the fly. This cross-section diagram shows a much harder physical challenge. Researchers place a food block at the very bottom of a deep, narrow, transparent tube. A bird's immediate reaction is to reach for it, but the walls are too tight, and the reward is placed too deep for their beak to reach. To solve this, wild magpies will actually seek out a perfectly sized stick, drop it down into the tube, and carefully maneuver the food out. This is documented tool use. It requires spatial awareness, forward planning, and an understanding of physical mechanics. This caliber of problem solving was once considered a primate specialty. Observing it in a wild bird places the magpie's cognitive abilities in the same category as chimpanzees and humans. But the most complex tests don't happen in a lab. They happen out in the open, where the biggest threat to a bird's survival is often its own neighbors. Members of the corvid family, which includes magpies and crows, rely heavily on caching. They bury thousands of seeds and scraps of food to ensure they have enough to eat through the colder months. To protect these stashes from thieves, a magpie will intentionally dig empty holes and pretend to bury food when it knows another bird is watching. The fascinating part is why they do this. Magpies who have stolen from others in the past use their own experience as a thief to predict the behavior of the bird watching them. They are projecting their own internal motives onto a competitor. Navigating that kind of deception requires a profound level of self-awareness and social intelligence. These cognitive feats present a biological mystery. Mammals rely on a complex outer layer of the brain called the cortex for higher-level thinking, and herds simply don't have one. This scatter plot charts brain-to-body mass ratios across animal families. It reveals corvids developed a highly dense neurological architecture completely independent of our own. When mapping out that mass ratio, the corvid data cluster lands on a level virtually identical to our smartest marine mammals. Pound for pound, their brain capacity sits right alongside that of dolphins. It proves that deep analytical thought is not a mammalian monopoly. It is a highly effective survival tool that the animal kingdom has independently evolved more than once. All of this context completely changes the experience of walking through a local park. When they can solve spatial puzzles, adapt to changing rules in real time, and manipulate its rivals, calling someone a bird brain doesn't really work as an insult anymore. Look closely at that flash of black and white in the branches. You are watching a feathered ape, an intelligent strategist, constantly recalculating its survival on the urban chessboard.